either, and welcome to Magic. In this video we're gonna measure the performance of the Magic task scheduler. Here I've added a single C# file into my magic.backend inside of the slots folder. There's a link in the description of this YouTube video for where you can find this file if you want to reproduce my little session. It basically contains three classes, which are slots, all three of them, and what they do is that the first class, called job count, simply resets number of currently executed jobs. Then it creates a new manual reset event, and then it sets the max jobs to whatever input value is provided through hyperlambda. The second one increases the job count using an interlocked increment and increments the job count.count field and checks to see if the current count is more than max jobs. If it is, then it sets the wait handle that is field of the first class job count up here. Then the third slot simply waits for the manual reset event to be signaled. Now, all in all, this allows me to do the following, where I basically have a file in my MISC folder, hyperlambda file, called testing scheduler. Now this file, here I can set the max iterations. I can set it to 4000, and then I can save it if I want to. And these are 4000 jobs that are created. Then I reset my job count, passing in the maximum numbers of jobs I am creating. And then I have a while loop down here that basically iterates for max number of iterations, implying 4000 iterations here of this particular lambda object, which basically creates a unique job name, and then it creates a new task. And none of these jobs are persisted to disk. However, each job invokes my increased job count. And then at the bottom I have a wait for jobs invocation here. Now, all in all, what this basically results in is that I'm capable of creating 4000 jobs here and waiting for every single job to finish executing. These are immediate jobs, implying they will be immediately executed on a different thread though, may I add. Background thread, and none of these jobs are persisted, which is kind of important. All in all, this allows me to measure the performance of the Magic Task Scheduler, because once I click this evaluate button, whenever that button returns its HTTP requests, then this particular hyperlambda line of code has finished evaluating. And that will never return before every single job is finished executing. So basically, I'm measuring how much time is required to create 4000 Magic Task scheduled jobs and executing every single job. That is what we are effectively measuring here. So let's click the button. And they finished in 1.8 seconds. Let's try again. 2.16 seconds. Let's try again. 2.11 seconds. So basically, the Magic Task Scheduler allows you to create and evaluate roughly 2000 jobs per second. And of course, if I wanted to only create the jobs, then I could go to the scheduler here. I could turn it off. Then I go back to my files. Then I open up the MISC folder, the testing folder, and I open up this particular file. Now, if we uncomment this guy, and then we click save, and then we evaluate. So now we have created 4,000 jobs. That's what we have done. And that took us 1.8 seconds. If we now go to our evaluator and we do scheduler start, because the scheduler is not running now, even though it has 4,000 jobs, loading this page will probably take a lot of time, by the way. So you see here the scheduler is not running currently. If we start the scheduler, and then we need to come here, and then we need to open our testing scheduler, and we need to copy this line of code here. If we now go back here and we clear our HTTP requests, then once I click evaluate here, basically what will occur is that 4,000 jobs will be executing, and when the HTTP request returns, all of those jobs are done executing. Let's try it out. 0.7 seconds. And we can actually verify that jobs are actually running by going to the scheduler. And since all of the jobs were fire and forget jobs, none of the jobs are left, and that becomes the proof of that every single job actually did execute. So this allows you to use the Magic Scheduler on an extremely old computer, may I add. My MacBook Air is 5 years old. It's a piece of garbage. It's slow like syrup. So obviously on a real computer or on an actual server, this would evaluate 10 times as fast. But on a piece of garbage computer, you're able to evaluate 4,000 jobs in 0.7 seconds. That becomes roughly some 6,000 jobs per second. Thank you for watching. Have a nice day.